All right, guys. So now that we have kind of an understanding of um, acceleration and velocity and the position of the particle, we're going to look at, okay, how do you actually then look at an equation and being able to answer the same questions that we just did off the graph. So they give me a position function, right? So that's important to know. What is this function? So this is my original function. This is going to tell me the position of the particle. So when I'm asking for the displacement, I'm basically asking what is the difference, right, between where we started and where we ended up. So to figure out where we started, I just need to find x of 0 because that's when my time starts. So when I plug 0 into this function, right, I get 0 minus 0 plus 3, so I get 3. Okay, so that means that at x equals 0, I'm at 3 centimeters. Okay, so on the first 2 minutes, so that means when my time is 2, right, so at 2, okay, I have, so 2 to the third is 8, okay, minus 16 plus 3 is going to give me negative 5 centimeters. Okay, so remember my displacement again is the difference between the two, right? So I started at 3 minus where I ended up. So that's going to give me negative 8 centimeters. So that is my displacement, right? That is the difference between my starting point and my ending point. Okay, find the average velocity. So guys, average velocity is going to be going back to your average rate of change. Now, the first thing I need to do is I need to get my function for velocity. And remember, velocity is the first derivative. So I'm going to find the first derivative of t, which is really going to give my velocity function. Okay, and then when I take the derivative of this, I get 3t squared. Okay, the derivative of negative 4t squared is negative 8t, and the derivative of 3 is just 0. So this right here gives me my velocity function. Now, if I want to know the average velocity, this is kind of going back to the slope formula you guys always know, right? So my average is going to be that's your y2 minus y1 over x2 minus x1. So my x2 is 2. My x1 is 0, right? So that's my beginning and my end. And then when I plug 2 into my velocity function, minus 8 times 2, right? That's your y2. Minus, when I plug 0 into here, I just get 0. Okay, so what ends up happening is I end up getting on the top, okay, so negative 12 minus 2, oh, sorry, nope. So I get 12 minus 16, which is negative 4. Negative 4 over 2 is going to give me an average velocity of negative 2. And then don't forget our units, so centimeters per minute, right? Because that's what it tells me my units are in here. Now, if I want to know the exact velocity when t is equal to 4, all I have to do is just plug 4 into my velocity function, right? So 3 times 4 squared minus 8 times 4. Okay, so that's going to give me 16 times 3. And then I'm going to subtract 32 from that. So I'm going to get 16 centimeters per minute. Okay, that is my velocity at 3. Now for my acceleration, remember the acceleration is my second derivative of the original function or the first derivative of the velocity function. So if I take the derivative of the velocity, that's going to give me my acceleration. And so I have taken the derivative of this is 6t minus 8. So if I want to know the acceleration at t equals 4, I'm just going to plug in 4. Okay, and so I'm going to get 6 times 4 minus 8 is also going to give me a 16. Now keep in mind it is now, okay, centimeters per minute, like per minute, right? So squared. And is the car speeding up or slowing down? Well, I know that because they have the same sign, okay, it is speeding up.